Alright, so let's look at some more examples. So number 12 here, we have 2 to the negative first plus 4 to the first. And so before we can add, we have to evaluate the exponents, right? So going back to order of operations. So I have negative exponents here, so I'm going to drop them as if they were hot. And so this would be 1 over 2 to the first plus 1 over 4 to the first. All right, and we can think of those as invisible ones, right? Anything to the first power is itself. So we just basically have 1/2 plus 1/4. We can get a common denominator. And so we'll end up with 2/4 plus 1/4, which equals 3/4. All right, so that's our final answer there. Number 14. So here I have 1 over 25 times 10 to the negative fourth. So since I'm multiplying 25 by 10 to the negative fourth, I can actually separate those. Those are two factors, and so since I have 10 to the negative fourth, I can actually bring that to the top. I can flip it. So it'll become 10 to the positive fourth over 25. All right. And the rationale there is I can think of 10 to the negative fourth as 1 over 10 to the fourth in the bottom. And so, so basically I'm just flipping that to the top. So that I can evaluate 10 to the fourth. So remember, the power of 10, the exponent tells you how many zeros to put after the 1. So that's a trick with tens. So it's 10,000 divided by 25. I can evaluate that on my calculator in my head. And the answer will be 400. All right, number 16. So here we have negative exponents. So the negative exponent for the x is going to make me drop it to the bottom. The negative exponent for the y is going to make me flip it to the top. 6 and 5, we can't simplify or reduce those, so they're not exponents. So we just, if we can reduce them. But 6 over 5 cannot be reduced. So we end up with 6y on top to the first, but I'm going to leave that 1 out. And then on the bottom, I'll have 5x to the fifth. And that's as far as you can go. And by the way, now that we have negative exponents in the mix, we can talk about how we check if we're finished simplifying an exponential expression. So the 3 things that we need to check off are, and I'll probably write this on the board in class, but the 3 things we need to check off are our number simplified. So in other words, do we have everything evaluated in terms of our numbers? Like, don't leave a number with the exponent like we talked about before. We can evaluate that. Make sure you reduce fractions if you can, combine whatever you need to. So just make sure your numbers are simplified, right? And when I say numbers, I mean constants, right? So numbers that aren't variables. Okay, so our constant simplified. Then you can check, do you have positive exponents? So don't ever leave negative exponents, right? Like here, we could say if it was okay to have negative exponents, we could argue that would be simplified. But we always want to end up with positive exponents when we're simplifying exponential expressions. So that's another thing. And then, these don't necessarily have to be in this order, but the other portion that I want to mention is you should end up with one of each base. Okay, and so what I mean by that is if you start out with, and we don't see any here, but if you start out with two b's or two x's or two y's or three z's or whatever the case is, you should be able to combine those using your exponent properties and end up with one of each base. All right, and the other part to that is one exponent per base. So if you have a power raised to another power, you should simplify that so where you only have one exponent per each base. Okay, so I'll just put one of each base and one base per exponent, one exponent per base. All right, so if you check those three boxes, you're done. That's a way to confirm that you're done. Okay, so this is done, right? Numbers simplified, one of each base. I only have one x, one y, and we have positive exponents. All right, number 18. So we have a negative exponent with a fraction. So I'm just going to flip it. So 1 over y, when I flip it, it just becomes y over 1, or just y, and the exponent becomes positive. All right, so when you flip a fraction, that changes the sign of the exponent. And so y to the fourth power, can't really do anything with that, right? It's actually just y to the fourth. So I'm done there. Number 20, same thing, I'm going to flip this fraction because I have a negative exponent. So it'll be 3 over 4 to the positive second power. And now we can actually evaluate this, right? We can think of this two ways. We can actually just multiply 3/4 by itself, or we can use the power of a quotient rule and distribute the exponent, make it 3 squared over 4 squared. And so that would be 3 squared is 9, 4 squared is 16. That cannot be reduced. So that's our final answer.